I hope a few more will join, but for those who are on the phone, I'm welcome. My name is Dan Berg. I'm a member of the Environment Committee here at HFCA, and I'm going to be our starting host. As I said, I'm a member of the Environment Committee here at HFCA. We meet every month, and we're of course dealing with lots of important issues related to the environment around us and protecting our forests and our lakes and our wildlife, and making sure that our members continue to enjoy the healthy environment that we have around us. The board of directors of HFCA has recently passed an environmental mission statement, and part of that mission statement, I'm going to be very fast today because I want to get to our speakers. Part of the mission statement talks about bringing education to our members about ways they can participate in the circular economy, ways they can reduce their impact on the environment, and ways they can use less electricity, less water, less heat. So this session we put together today, this forum we put together, is really in the goal, the objective of meeting what the board and the environment committee we're doing. It's to bring information and practical information to our members. I would say that Marion's a fantastic resource for Hemlock Farms. She supports the environment committee, and she covers all of she's our director of community conservation, and oh, there she is, director of community conservation in the community. SEEDS, they're going to introduce themselves. SEED stands for Sustainable Energy Education Development Support. It's located in Honesdale. For those of you who don't know it, it's been around since 2008. And SEEDS has a goal which is committed to developing local renewable energy and sustainable living. And part of their work is education and offering the community forums like this. So we're really happy that two of their leading members have joined us today. Just to say, Larry Reeger, who you can see there. Larry is a professor, a sustainability coordinator at SUNY Sullivan. He calls himself the teacher of tomorrow's green workforce, which I really like. So this is an opportunity to teach some of today's hopefully green interested parties here in Hemlock. He's a key advisor to SEED. And Katharine Dodge, who you see there, is the co-founder of SEEDS and current chair of SEEDS. She's been working all her life on environmental issues, and what I liked about her bio is she's put her money where her mouth is and set up her own sustainable home in Lake area. She grows her own food and uses geothermal and solar to keep her infrastructure in place. So today's forum is really just an opportunity for our members to learn from their experience. I know I've been to visit the SEEDS office. They're a great resource. If you get the chance, go over to Honesdale and visit them. You saw some of the pictures of what they've done, both through education and through practical projects. And with that, I'm going to turn over the Zoom room to Katharine Dodge, who will take us through what SEEDS is and some of the practical suggestions they will make for our members here at HFCA. So thank you, Katharine. Thank you, Larry. Thank you, Marion. And the floor is yours.
Okay, thank you, Dan. And thank you, everybody, for coming to this program on this beautiful day. We'd all rather be outside, I think, but here we go. But we are a local nonprofit founded in 2008. We have a part-time executive director and a bunch of talented volunteers. Member benefits include efficiency and solar assessments. And membership categories and other benefits are on our website, and you can sign up for our newsletter there. So our mission is to promote energy efficiency, renewable energy, and sustainable living in our communities. The goal today is to help you save money, provide ways to make your building more comfortable, cut greenhouse gas emissions, and present renewable energy information. Efficiency first. This is what SEEDS puts our energies into mostly. Before investing in expensive renewable energy, reduce your energy consumption. The least expensive kilowatt is the negawatt. Solar installations are sized for the needs of your home, and you don't want to go out and invest in expensive solar panels until you've made sure that you've cut your energy use as much as possible. Let me go back to that for a second. Here's an example. There was a man in Hawaii recently who wanted to install solar. So he got a quote before doing any efficiency upgrades. So he went to a solar person and they came in and they said, okay, you need 35 panels and 3 power walls, which is a power backup system, and it will cost you $39,000. Then he went back and he did some simple upgrades. He changed out his light bulbs to LEDs. He put in low flow shower heads, checked his faucets for drips. He put in power strips and timers. He put up a clothesline. And why wouldn't you do that if you were in Hawaii? And he upgraded 2 refrigerators, all for a total cost of $1,300. Then he went back and he got a solar assessment again. The new quote was 23 panels instead of 35, and only 1 power wall for a total of $15,500. That was a savings of over $20,000 just by doing $1,300 of upgrades. He later added a solar water heater, and then his house was at net zero, which meant that he was making all the energy that he needed to run his house. You can go to pplelectric.com. If you haven't already, you should set up your account there so that you can see your bill online. And you can track hourly, daily, and monthly electricity usage. It can show 2 years of data. This happens to be my bill that I'm showing you here from February of this year. The top graph shows the amount of solar that I generated in February, which wasn't much because we had so much snow cover. I wish I could have shown you a better month. And so the next one shows how many kilowatt hours were delivered to me from the lines. And then the last one was a combination of the two, subtracting the solar that I made versus the kilowatt hours that I used. And that light blue line is the daily average temperature. So you can really analyze your energy use by going to this billing site at PPL. Larry?
Hi, everyone. My name is Larry Reeger, and I'm a volunteer with Seeds. So let's share some experiences together. Let's just start with the term building science. And that's a term I talk about often in the classes I teach. And we're going to start with a building envelope. And so, what is a building envelope? The goal of a building envelope is to make the conditioned space as comfortable and as efficient as possible. And so, what can make that space not so comfortable? And one of the first things that comes to mind for me is what's called chimney effect. And that might be a new term to you, but chimney effect, you might think about, you light a fire and the smoke goes up the chimney. That's chimney effect. But in your home, it's happening every day. And in the winter, it can be extremely strong. You open a basement window and you have a second floor window open, you're going to feel cold air rushing in the basement. And when you're on that second floor window, you're not going to feel any cold air coming in at all because it's rushing out. Heat is rushing out. And so chimney effect in the winter would be cold air rushing in the lower levels and hot air rushing out on your upper levels. However, you're going to see in the coming slides, we have air leaks, and we're going to show you how chimney effect affects all those air leaks. Go ahead, Kathy.
Okay, if the kid next door threw a baseball through your window, made a big hole, you'd fix it right away, right? Well, a lot of little air breaches in your house can add up to something like a hole in your window. So that's why you want to take care of all those little things, because they can add up to that big hole. So here are some air breach points in this diagram. It shows what Larry was just talking about, where the cold air can be pulled in from the bottom and the warm air escapes the top. Nature abhors a vacuum. So if air is leaving the top of your house, other air is going to get pulled in. So now we're going to go through some specific breach points. It's really important to fix the breach points in your attic, because again, that's where the warm air is going to rise. On the left here, you see an old house with a door to the attic. You could be insulating that attic door and checking the weather stripping around the edge of the door to make sure that it's really doing its job, and replacing it if it isn't. And then an attic hatch, like the one over on the right picture. This is a pull down ladder system. And this is one that my husband made for us. And it has a frame that he put around the top of the hatch, and then put a foam core board on top of that and nestled that down. And so that when you want to get to the attic, you just unhook that and lift the foam core board away, and then you get to the attic. And Larry?
And so what we're trying to do with you today, just so you understand what we're trying to do, is we're trying to explain how you can lower your energy costs. And then we're giving you tips and examples. And so Kathy just showed you the example of the attic hatch, which is a really huge, most people do not do that. Most people do not do that. I bet most of you do not have an insulated hatch. Most of you may or may not have insulated outlet covers. And so that's our next example of something that you could do very easily. You have to do it safely. Be careful what, I'd never recommend that you start messing around with electrical outlets because it can be dangerous. If you have confidence and know what you're doing, you can install insulated outlet covers. And something else to consider is there's a lot of air being lost through recessed lights. Once a home is built, you really can't do anything about it, but that image on the right is showing a recessed light. That's a major cause of heat getting up into your attic. Anytime you can, you want to do flush mount lights, like the lights that just mount on the surface. Most of you probably bought the home already built, and so you don't have that choice.
And Larry, what about insulating the recessed light in terms of the insulation around it? You don't want to put it right close up if it's a hot light, right?
Right. And so the image on the right is showing a canned light, a recessed light. There's two different kinds of lights. There's one where insulation can touch it, and there's one where insulation cannot touch it. And so the image on the right is that canned light where insulation is not allowed to touch it because of fire hazard. And you basically build a insulated box, and then you insulate around the insulated box, even though that image doesn't show it. You'd have insulation all around that box. Thanks, Kathy.
Thanks.
So here's an example of more air breaches. So we're talking about that. I was talking about that stack effect. And so let's look in the top right. You can kind of just see a hole where maybe a telephone wire is running into the home. Well, that stack effect, that could be going into your basement. And that's like, larger than the diameter of a quarter. And that can be a lot of air rushing into your home year round. And that could be wet, moist air, or that could be, just adding cold air to your space. And so you want to look at all the different breaches. The lower right is just a conduit going through a concrete foundation. And on the left, you can maybe see like some kind of dryer vent or something's been broken and the baffle's just not working. So there's all different ways of repairing. You can repair with caulk or expanding foam.
And large holes like that one on the upper right, you might need a little extra material, like a piece of wood or something to stuff in there and then put caulk around or something like that.
And so staying on that theme, you want to, in the classes I teach, I can use a thermal imaging camera, and we can walk around and see where heat is seeping out past a window frame or a door. But just by simply using your hand and on a cold, when it's cold outside and it's warm inside, that's one of the best times to check. You just take the back of your hand and just move it around your window, around your doors, around the edges of your doors, and you'll find air leaking. And so what do? You can do weather stripping. You can do caulk if it's a small little gap. As it gets bigger, you can use some forms of expandable foam. But be very careful. If you're going to foam around a window or even a door frame, there's a high expanding foam and a low expanding foam. You definitely want to use the minimal expanding foam around windows and doors, because it really can affect how those windows and doors work. When it comes to doors, don't forget to adjust your strike plate so it's really holding your door tight against that weather stripping. That's another way to adjust and keep that cold air out in the winter. And so we're back on, we're going to kind of just focus in on the attic. And one of the most important things you can do in your attic is insulate that hatch that goes up in there. Maybe it's just a little 2.5 by 2.5 square that's in a closet, or maybe you actually have a door like Kathy had where you climb up in. Insulating that hatch door is one of the major concerns. And we're going to talk more about why it's such a big problem. But thermal bridging is a term that I talk about often in the classes I teach. And the image on the right is inadequate insulation. The image on the left is appropriate or more appropriate insulation. The image on the right, you can see the fiberglass insulation is is not really even above the those roof joists that you can see. That would be like an attic floor. You're going to have the cold air can actually move. It's like the heat, the cold air from in that attic can actually transfer down into the room 3 times faster than if there was insulation on top of that. And so that's inadequate on the right. On the left is a blown in cellulose or some form, and then you can see there's some pink baffles. You want your attic to be flushed with fresh air. And so that's what you can kind of see in the top right, where it's showing exhaust. Ideally, you do have 2 different ways of insulating your roof. This is one method where you don't worry about hot air or cold air in your attic. You don't power ventilate it. That's the wrong thing to do, because that's pulling heat up out of your home or pulling the air conditioning out of your home when you do power venting. You naturally just want to let that air rise.
And that those baffles are keeping the soffit area open so that there's air circulation. So those baffles keep the insulation from covering those soffit vents.
This is a weak point. So let's just kind of focus on the right for a moment. There's a term, it says seal plate on the right. It says seal plate foundation wall. Most of us probably live in some kind of concrete or block foundation, and then the wooden frame of the home sits on top of that concrete and or the poured foundation or the blocks. That seal plate is a leaking point. That's where a lot of cold air. Sometimes it's sealed, sometimes it's not. Sometimes they put down a gasket, sometimes they don't. My home, for example, has blocks. It was not, when I bought it, there was no seal. I could literally see right outside. And so picture, an 1/8 inch gap basically all the way around your basement. And that's how much air was coming into my home. It was just barely contacting anywhere. And so these are areas you want to look for. You want to caulk shut. You want to spray foam if necessary. Again, we're just showing some more examples. We're going to kind of shift gears a little bit onto wall insulation possibly, or even a little bit of basement insulation. On the left, you can see some fiberglass insulation. I'm going to look where it says fiberglass and it's pink. That's an ineffective way to insulate your wall, which most of us have. That's how most of our homes are built. If you have a high quality installation, you would not see that electrical wire running across. They would have split that fiberglass and run it behind and in front of. It would not have tucked it in. That electrical outlet is not proper. Where it says dense packed cellulose, that's a paper mixture that was wet and then blown in and then kind of ground off. You can see how well it goes around that outlet. That outlet is truly sealed. And then there's a couple other examples of closed cell foam. That looks like that's probably in a basement, possibly, or maybe a ceiling. I'm not sure.
No, that's our basement actually, and that's closed cell foam, which is soy based, which we made an effort to try to find a friendly way to use closed cell foam.
But you can hire a contractor to spray your closed cell foam. You don't have to hire Kathy and Pete.
No, we didn't do it. We hired somebody.
Excellent. All right. So so when it comes to your basement, this is a pretty important takeaway today. So we're just going to stop we're just going to pause. I want you all to think about, do you even have a basement? So that's your first question. And if you do have a basement, is that part of your envelope? So we started this talk with, we want to make your envelope comfortable. Many homes, the basement is really not a conditioned space, and you're not worried about keeping it the same temperature as the rest of the home. And so so if you're thinking about your envelope of your building, even you're thinking about building science, where is that line? Is it the floor of your basement, or is it the ceiling of your basement? And oftentimes it's the ceiling. And when you go into your basement, you're really not concerned with heating and cooling your basement. And so so think about that. Just think about your basement and think about if it's part of your building envelope or if it's not part of your building. And then you start insulating and air sealing based on what you decide. And the last thing we're going to talk about at this moment is the vapor barrier, because we're still in the basement. This is an example of fiberglass insulation that's in the ceiling of the basement. And so we've said this basement is not part of the envelope. and everything above that floor, that ceiling, is part of the envelope. And you will see there's a problem here. So a vapor barrier, or more accurately, a vapor diffusion retarder, is a material that reduces the rate at which water vapor can move through a material. In this picture, there's something wrong. So it should be part of a moisture control strategy for homes, and that barrier should always face the conditioned space. And so they installed this fiberglass insulation incorrectly. It should be flipped over, and that paper should be up against the plywood, the decking of that first floor.
And that's something we found in a lot of homes that we were assessing, that they did it backwards. I mean, it looks so neat, and it just made sense to not have all that fiberglass showing, but it was backwards. So now we want to just talk a little bit about moisture management. And there are various contributing factors, and we're going to take each one in turn. Back on you, Larry.
So I think it's really important to understand that on 2 slides back, we said that the vapor barrier is the wrong way. We're concerned about mold. We're concerned about decay. We're concerned about dust and mites. All right. So that's what we're concerned about. And by putting the vapor barrier the wrong way, you've just created an environment where that can happen. And so, in this slide, we're really kind of talking about humidity and where it comes from. So it can be from the weather from outside. It could be hot and cold water pipes running through a cavity. It could be from cooking. Have you ever seen your toilet sweat in the summer? It's because your humidity in your home is possibly high if you're not running the air conditioner, and the water's coming in either from city or from your well, and it's cold. It's 50 to 55 degrees, and you have this problem. It's called a dew point. The dew point is when condensation forms, and I think we have an example of that on the next slide.
There you go.
There you go. So there's a copper pipe, and it's got water dripping on it, and you might think, oh, it's copper, it's okay, no big deal. But what if that's inside your wall? What if that's inside a cavity, and that water drips down off of that pipe? And it does it for 20 years. You're going to get rot. You're going to get mold. You're going to get poor indoor air quality. So one of the really simple things you can do is insulate your cold water pipes. And I actually like to insulate hot and cold because it can benefit when you're heating your hot water, but it can also reduce that mold when it comes to cold pipes also.
Okay, now a little bit about precipitation. Here's some ways that you either can or shouldn't manage rain. These rain barrels are ones on our property here, and we collect that rainwater off our barn, goes into these barrels, and we use it for watering the garden. You can do this off the edge of your eaves of your house, and that will cut down on water just running down on the ground and maybe into your basement. And over on the lower right, you'll see a way that you can also move water away from your basement by this little sluice area that just pushes the water out into the vegetation. And I love this little picture down in the bottom there with the watering can coming off your gutter. That slows the water from being a rushing river into this little bit of raindrop stuff coming out of your watering can into some vegetation that will absorb the water and let it, ease into the soil more slowly. That picture in the middle, it shows that green along the siding. That happens to be our house. And it shows poor design. Our roof way up above did not have a gutter. So the roof was just pouring water off onto this little shed roof here over our back door, and then running down the back little corner there and running down the siding. And eventually that's going to rot our siding. So you need to think about where your rainwater is going and try to ameliorate any problems like this. And then of course your rain gutters. If you have a forest growing in your rain gutter is not functioning properly. You need to keep your rain gutters cleaned out.
And can I just add to what Kathy said? I recently was in the basement of a home that has a stone foundation, and they had the gutters were full of pine needles. But when you went down into that basement of that stone foundation, it was moldy, damp, wet. And so those gutters play an important role. Okay, so let's talk about snow and ice. And again, as a teacher, it's so fun to go out in the wintertime and see those big icicles hanging off a home. And I just look at my my students, they could be young or old, and I say, what's going on there? And they're like, oh, it's an icicle. Well, right away, my energy management hat goes on, and I'm like, no, we have a problem inside the house. So in this little image, you can see it shows heat duct. And you can see those little figure eights. That's an image of insulation. That's a little figure eights or little V's and circles, teardrops. You can kind of see that's insulation. But there's a heat duct that's on the outside of the envelope. And that heat duct is releasing heat and it's melting the snow on the roof. And so this year has been a perfect example where we had, 16 inches or more snow at a time, maybe laying on our roof. And so there was icicles all through our communities, and every one of those homes is an opportunity that could be solved. And we want to just be aware it's called ice dam. And so what happens is the water runs under the snow against the shingles, and when it goes to drip, it freezes, and that's why you get those icicles. So this is an example of a either a poorly insulated attic. It could be that that hatch door that doesn't have foam around it. Maybe heat's getting up through that hatch door and melting the snow in the attic. It could be heat duct, like heat duct work. I know in my past, before I have learned about this topic, I built a home. The contractor put the heating and air conditioning equipment in the attic, but the insulation was, down on the floor, but the heating equipment was above it. And many of your homes will have been built like that. And so you're going to see some examples, I believe, coming up on you just really need to properly insulate that ductwork and try to minimize that heat loss.
And you can go around your neighborhood and look at your neighbors' roofs and tell whether or not they're having a functioning attic by whether they're holding snow on the roof. If there's a good bunch of snow on the roof holding, that means their attic is cold. But if they have patches where the snow has melted, they have problems, right, Larry?
Yeah, it just means that they're spending money. It's not a problem. It just means you're spending money and heating the outdoor environment. That's how I think of it. You're just spending money. So it's up to you if you want to spend that money or not. And it can be tricky to fix. If there's a HVAC system up there, it can get a little tricky to take care of that. You want to, when you're designing new homes, you want to get it inside the envelope.
Okay, now I'm a bird person, okay? So I had to pull a little bit about birds in here. Birds like ducks and geese. Have you ever wondered how their feet can standing on the ice or swimming around in very cold water? Well, they regulate the temperature of their feet by a counter current heat exchange. So as the venous blood and the arterial blood pass each other in their legs, they do this heat exchange thing. And so maybe we've learned something from them. And Larry, take it over.
Can I stop you 1 second, Catherine? Larry, since it's come up in the insulation section, I see somebody has asked a question in the chat room about insulation. And the question is actually, does Seeds offer any guidance and recommendations regarding companies that are good at insulation in the region? Or is this something you would rather leave to the commercial market?
We do not give advice on who people should go to, but we do sometimes have lists of companies, but we don't say you should use this one over another. I haven't checked our website very recently to see whether we've updated that or not. But yeah, as a nonprofit, we don't advocate one company over another. I hope that answers the question.
And as I'm leading in, I'll be able to answer some questions, Dan, at the end of this talk. A really important takeaway that I'm going to say at the end of this talk will be, it's always pertinent to get 2 or 3 estimates on every job. And what you will learn is something new with each quote. Company A, here's what I need you to do, and what do you think I should do? Company B, here's what I need you to do. What do you think I should do? Company C, you do the same question. Here's what I'm asking you to do and get a quote for. What do you think you could do to help me better insulate my home? Now you have 3 quotes and you've asked that question 3 times to 3 different contractors that might be up in your attic, and they provide you with some information. And if it's all consistent, then you can go on based on price if you decide. Or you might have learned something new and you come back to those same 3 contractors and you say, you know what, I'm going to do blown-in insulation. Company A, can you quote blown-in insulation? Company B, can you quote blown-in insulation? Company C, can you quote? Because you've learned something from all 3 of them. That's my advice. If you go with one installer and just let them do what they want, you're probably not going to get the best job unless you got lucky and met a company that's spot on. That's my advice. Okay, so I want to kind of keep the good question, Dan, or whoever put that in the chat. It's a really good question. Let's just kind of keep going on ventilation. This is a really, really important topic. In the sake of trying to keep things moving, I can talk about it more at the end of the this talk. But these HRVs and ERVs is how we can build really tight building envelopes. And so today we're building homes that are much tighter than they used to be. I've lived in homes with no insulation, with no caulk, no sealer, and you just you know, with fossil fuels, you just try to keep that space warm. And it costs a lot of money. These HRVs, what they do is they actually constantly circulate stale air out of your home, and they bring in fresh air in. Because with these new tighter homes that many of you might be living in, these heat recovery ventilators or energy recovery ventilators is what keeps your house fresh. But they also do it in a way that it's very energy efficient. Because what it does is it mixes you know, in the winter, it would bring in cold, fresh air, and it mixes it with the warm, stale air in the home. And so you get about a 10%, you know, 10% of that cold air ends up coming into your home and 10% of your warm air goes out. It's very energy efficient, but it keeps your indoor air quality really high. And this is something that almost all new homes are utilizing because of how tight they are. All right, so we've talked a little bit already about attic ventilation, but in this one, what I really want to talk about is I want to like re-emphasize the importance of ventilating your attic. And so you have 2 different ways of insulating your attic, and one of those ways is what we've already seen, where you have fresh air coming in, where it says the intake. It kind of just circulates up through your attic, and like Kathy said, you know, it's cold up there, the snow doesn't melt. And you just have a nice fresh flush of fresh air up there. There's another form of insulating your attic. It's called a hot roof. That's where you literally maybe do blown-in insulation right up inside the roof rafters, like right where the plywood and the shingles are. That's not necessarily recommended in northern climates because of extended snow on your roof. It's not necessarily the preferred method. You can have a lot of sheathing, dry rot. When you take the shingles off, you might take them off 15 or 20 years down the road, and you'll say, "Whoa, what's going on here?" It can be. It's in the southern or not, like down in Texas, the dry arid locations. It's not really a problem, but here up in the Northeast, it can be a problem. So typically, we try to insulate that attic floor is the best practice for us.
Okay, and then there's a little bit more on venting. Some people have a whole house ceiling fan, and really a well-designed and properly insulated and ventilated house should not need a ceiling fan, and they are energy hogs. So if you have one, you should definitely box it in the winter, just the way you box the attic hatch in, because the flaps on the bottom side, on the conditioned space side, may not really close all the way. So you should box it in the winter, but make sure that when you use it in the summer, you remove that box, otherwise it won't function. So if you have a gas heater, obviously that needs to be vented as well to the outside. And again, any kind of penetration in your foundation, make sure that you have caulked around it so there isn't an air breach.
And if I digress to what Kathy's slide just said, is building science says never use home fans like that into the attic. And the reason is Think about that humid day. Think about that storm that's rolling through in July. You're like, wow, the humidity is just dripping off me. I'm so sweaty. You turn that fan on, you're drawing all that humidity into your home and maybe pushing it up into your attic or maybe pushing it out the side of your home. And you're thinking, oh, I'm moving air. But what you're really doing is introducing all that moisture into your home. And so on this slide, we have bathroom venting. It's really important. So when you take out the shower, you turn on the fan in your bathroom. It's in this slide, you can see black mold on the sheathing. You can kind of see a red circle. It's basically venting moist air into your attic space. And that's just going to create mold and rot in your home and shorten you're going to need to possibly address that in the future at some point in time. You definitely want to ventilate completely out and away from your home.
Okay, and now, you should make sure that you don't have a radon problem in your house. It's a radioactive gas. It's heavier than air, so it's mostly a problem in basements or on lower floor of your house. It's odorless, so it's a good idea to test for radon. And if you have a number which is above 2, you should have some concern that you get a good test. And if it's over 4, you should definitely consult with a radon abatement specialist.
And I just keep digressing because my mind is spinning here. Radon,
But-
remember how I talked about stack effect? You're pulling radon gas up through your home. It's so very important. I have children. I think about the air that we're breathing. And when you have holes up in your attic through recessed lighting and you have radon gas in your basement and you have holes in your basement, that radon gas is just seeping up through your entire home. So that's what stack effect can do. So this next slide, common alternative energy options. So let's just talk about heating. So if I were to throw a slide up on where do you spend most of your money, you're going to see a lot of us spend most of our money in heating our space, cooling our space, heating our hot water. And so here's some alternatives. Geothermal, maybe you've heard about that, ground source heat pumps, and then there's also some air source heat pumps. And so ground source heat pump is when we use the Earth's 50 to 55 degree temperature, and there's technology out there, it's called ground source heat pump. And we can take that temperature from the ground and we can convert it to heat. And so usually it's about a 40 to 50 degree rise. And so we can take 55 degree temperature and turn it into about 95 degree heat and blow. You can either circulate hot water or you can blow air into your home. And that's how Kathy Dodge heats her home with geothermal. Another thing called air source heat pump. Today, the air source heat pump, in my opinion, is going to take over. Like in the next, it's already taking over. Air source heat pumps take warm air, even when it's cold outside, even when it's minus 15. Air source heat pumps. If you get a sub-zero air source heat pump, it can take heat out of the air when it's minus 15 and put like 90 to 100 degree temperature air into your home at a really low cost. And so today for, around $3,000 to $4,000, you can install these things called mini splits, and they'll heat just like a large room, 1,000 square feet. For $3,000, you can kind of, heat a basement with it. Kathy has a second attachment that she rents out, and I think they have an air source heat pump for that space. It's like a big open space. But sub-zero air source heat pumps can also heat entire buildings. They have them for large buildings. They heat entire homes with multiple rooms. And so it's something to consider the next time that you are thinking about upgrading your heating system to operate in a low, be very affordable to operate. So what can I say about air to air source heat pumps? I actually have that exact model in my basement. I installed it 3 years ago. My wife used to, we did not do disposable diapers when my kids were younger. We hand washed our diapers. That means that washing machine was going a lot. We saved $30 a month by installing this unit. This unit here cost around $1,200. I installed it myself. I got a $300 rebate from PPL. So that means it only cost $800. I think I end up with some other rebate somewhere else. Maybe on my taxes, my federal taxes, I got a rebate. I paid for that heat pump in less than 3 years. And so that's a $1,200 hot water tank. I took out a perfectly good electrical hot water tank, saved $30 a month. In 2.5 years, it was paid for. that air-to-air source heat pump has a 10-year warranty. So it just makes common sense to do it. There is one downfall to air source heat pump hot water tanks, is it takes heat out of the air. And so in using my home as an example, if when I'm doing, we sort of utilize our basement where that hot water tank is, it can lower the temperature in the winter, maybe below what you want it to be. And so that sometimes can be a problem. The next thing you have to be aware of is it takes condensation out of your room, which is great. So if you have a damp basement, it's actually removing condensation, but you have to be able to run it to some kind of water outlet or drain.
One other thing about those is that they are a little bit taller than the traditional water heaters, right? You have to have headroom for those.
No, not really.
Oh, no?
No, I
Okay.
mean, no, I would say no more than a foot extra, Kathy.
Oh, okay.
There's different models. There's definitely different models.
Yeah. Okay. And now down to the cellar here.
All right, so ductwork. So there we go. So this is a perfect this is a good install. So on the left, you can see that they've used they put the heating and cooling system. I don't know if it's cooling, but I assume it's heating and possibly cooling. That's an air handler with all those pipes and running off, all that ductwork running away. That's inside the envelope, and I can see an oil tank, so they must have an oil burner, some kind of oil furnace there. And so what am I looking at? Very efficient. You have to be really careful on how the ductwork is run. So when I see flexible ductwork, I cringe a little bit. That's the cheap way to install ductwork, because every time that there's a strap, it restricts the airflow a little bit. So you want to make sure that all of your ductwork is open and free flowing as much as possible and not kinked, so that your system is not working too hard. And on the right, we have, it's called mastic, where you, if you have a lot of galvanized steel ductwork, this is the method that you use. Most of you have heard of the term duct tape. That's from 20, 30, 40 years ago, where they used to put tape on your ductwork. We don't do that anymore because that tape just peels right off after 10, 20 years of heating and cooling. We use mastic nowadays to keep that heat inside that ductwork. And another way to think about it is you're paying for that heat to be created. And every time it gets lost in a wall cavity or maybe in the basement where you don't want it, you're just wasting money again, just heating spaces that don't need to be heated. Or if it's going into an attic space because your heating system is in the attic and it's leaking heat, then you have ice damming, you have water, you have snow on your roof, you have ice damming, maybe you're shortening the life of your roof because of the ice damming going on.
Okay, now think about the outside of your house. Replacing paved or bare areas in your yard with ground covers can turn down the heat by about 10 degrees, which is pretty amazing. My house is always cool in the summer because I'm surrounded by trees on 3 sides. The 4th side, I have my solar, so I want it to be open. And as Larry mentioned, I have geothermal heating and cooling in my system, but I only use my cooling maybe 2 or 3 days a year because of that cooling effect of the trees around my house. Now, I know a lot of you in Hemlock Farms have a lot of trees around you, which is nice. It's important, though, to keep the soil and the plantings far enough from the foundation and from your siding to allow air circulation, because you could have moisture buildup if the plants are right up against the house. And also pull them away from the siding because you can have rot and deterioration.
Another thing you can do is when it comes to shopping for appliances, just be aware that clothes dryers, washing machines, refrigerators use electricity 24 hours a day, 7 days a week, every day of the year. So a really simple thing to do is you don't have to be rocket science, just buy Energy Star appliances. I'm going to keep us moving, Kathy.
Right.
Phantom, vampire power, or phantom loads. That's all those. So you get up in the middle of the night, you go to get a drink of water, you're wandering around and you see a red light flashing, a green light flashing, a blue light flashing, your computer's charging, your modem's going. So just be aware of all these loads. That TV that's sitting there waiting for you to click the on button, it's drawing load. And so, one TV is not going to make that much difference, a couple dollars a year, a little bit of electricity. But when you have multiple TVs, multiple computers, And I'm not saying turn your modem on and off every night. Use these power strips and turn off those phantom loads when it's appropriate. So what are the top 5 energy vampires? Computer equipment, like I said, TVs, your surround system, anything that's sitting there waiting for you to hit the on button, like that remote control, they're drawing energy. Even the clocks inside your microwave and your DVD player are drawing energy every day.
Okay, one of the easiest and quickest ways to make a big dent in your electric bill is to change out your light bulbs. The incandescents, the old ones that, you know, if you had that on, you couldn't put your hand on it after it had been on for a little bit because it's pouring out heat as well as light. And that's a waste. And LEDs, now you can put your hand on it when it's been on for a while because it's just turning out more light than heat. Here's a chart that shows the different levels of lighting efficiency. Now, if you look at your standard 60-watt bulb and then travel over to your LED on the same line, it says 13 watts. That does not mean that the LED is giving out less light. The wattage is the amount of energy it takes to make the bulb work. What you want to do is go over to that left-hand column where the lumens are listed. That's the amount of light that the light bulb puts out. So a 60-watt incandescent is going to give you 800 lumens, but so is that 13-watt LED. That's where you get your huge energy savings. And you can get, in the LEDs, you can get a wide range of color variation from very warm to very cool, and that's the Kelvin rating. And that some of the packaging gives you the Kelvin amount, but it's also might just show you a chart of warm to cool. So you just pick what you want. And these LEDs are now coming in all kinds of sizes and shapes. And some of them look like the old-fashioned Edison bulbs. I mean, they're getting really very varied. So you can pick all kinds of things from there. And we had one person who we did an assessment for, and he immediately changed out all his light bulbs. He cut his energy bill in half by just switching out to LEDs from the incandescents. That's huge. Okay, water conservation. If you're on a water meter, you obviously can save money by conserving water use. And if you have your own well, then your water pump will have to work harder and longer the more water you use or waste. Okay, so fix your water leaks. Just a minute, I'm kind of looking for my notes here, make sure I don't forget. Lost my last page here.
I'll take over, Kathy.
Yeah, okay, go ahead.
So again, Kathy's just talking about installing high efficiency toilets. You know, like when it comes to toilet, the old fashioned toilet, you know, you used to flush it and you would flush multiple gallons, 2-3 gallons. Today, most of you probably have more high efficiency toilets. You want to maybe consider dual flush toilets if you need to replace that. And a really simple thing to do is select water sense fixtures. And so, you know, you find yourself at a remodeling store, you know, and you just wanted to be a little bit more energy minded, just say, hey, I want you to only show me products that meet the EPA water sense program. Yeah, you can change the slide.
No, well, okay, I just want to mention, if you have a lawn, try to cut back on its size. It may be pretty, but it needs to be watered and mown using fossil fuels often. And it's a useful habitat, not for anything but maybe a robin, your badminton, your croquet game, maybe your child's swing set or your lawn chair. But you can really save a lot of energy and time if you cut back on your lawn. Hot water conservation, Larry?
Yep. So just again, wrap your hot water pipes, you know, that'll help deliver the hot water a little quicker. With today's high efficiency dishwashers, most of them have what's called a booster heater. So you can just set your hot water tank at 120 degrees. You don't need it any higher than that. That's going to save you 6 to 10% of hot water heating year round. You got to think about this, you're heating year round. Some dishwashers require 140-degree temperature, but those are mostly older dishwashers. So almost all dishwashers today just require 120 degrees. Yeah, and when it's possible, I always turn my hot water tank off. My hybrid hot water tank has a vacation mode. I go down, I beep it on for 5 or 6 days. There's a little button, I go deet, 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 deet. I just turn it down. 5 days later, the hot water comes back up. When I come home, the water's still hot, like nothing happened.
Okay, now we're just going to talk a little bit about solar. Why go solar? Well, over the long term, you can save money. It's good for the planet and future generations, and it promotes green jobs. Seeds has trained local solar installers who have gone on to become certified, and so we have helped the local industry. The kinds of solar, there are 3 main technologies. There's passive, which is simply intelligent architecture using highly efficient materials, using the sun to best advantage. No building today should be built that is not thinking about some of those passive ideas. Thermal is, of course, heating hot water with solar panels, which are different from the photovoltaic ones, which are making electricity. And you can see that we use that even in space.
So we learned, don't run out and buy your solar array just yet. Do your energy efficiency upgrades, and then think about what kind of solar system you want. And so we have what's called a grid-tied solar system, grid-tied. And so the majority of all homes have what's called grid-tied. That's where you make electricity. You see those PV modules on the roof. Maybe they're in the yard. It creates what's called DC electricity. It runs through an inverter. It gets converted so that your home can use that electricity, or the electricity goes off to the grid. A small percentage of homes have battery backup, maybe that Tesla battery wall that Kathy mentioned at the beginning of that home in Hawaii. They had a little Tesla battery bank power wall. Well, so, just picture having some batteries that are going to power your critical load. That freezer, maybe a few lights. So when electric goes out for multiple days or half a day and you just can't live without power, and you need to recharge that freezer, you want to be able to listen to the radio and get emergency updates. Some people will have, you'll have a solar array that's charging a few batteries, and then providing and offsetting your electric use. And your last one is called completely off grid, that cabin in the woods, where batteries power your entire home. And that's called an off-grid system. That's the most expensive way to of the photovoltaic solar systems. This is where you live off the grid and you've chosen not to be connected to the grid, and you must really work with nature. We go 3 or 4 days with no sun, 12 inches of snow. What is your backup plan? Most off-grid homes have maybe a generator as a backup using fossil fuel. So just the terms are grid-tied with battery backup, and off-grid. If any of you are interested in solar, you're probably looking at the grid-tied.
Okay, now remember that solar systems are sized according to your energy use. Siting and sizing is important. You look at orientation of your building, and you look at your shading. So I'm not going to go into terrible detail here. You can see more on our website on all the details of our solar stuff. But if we did come to your house, if you're a member of Seeds, and gave you a solar assessment, we would bring with us one of those solar pathfinders, which is shown in that little picture there, which can tell us immediately where your shading is all year round on that graph. It's amazing. So the sizing, it's usually limited by the physical site issues like the size of your roof, and of course your available budget. What will solar PV system cost? As of 2019, it's about $2.75 a watt, unless you do DIY, do it yourself. So it takes away the labor. It's about $1.75. And by the way, Seeds runs a solar do-it-yourself workshop every year. I think we're going to have one late summer this year. And then there are some permitting and inspection costs which vary depending on where you live, right, and what townships, for that matter. And again, PV installers, look for a NABCEP certified installer. That's North American Board of Certified Energy Professionals. They will come and do a full, sorry, what's the word?
Solar assessment. They'll
Thank
tell you
you.
how much, yeah, they'll be able to tell you how
Well,
much
yeah,
energy.
they'll be able to give you a quote. Yeah, that's what I meant. Okay. And so how do you make your money back? By income tax credits, and because the new administration is not the old administration in Washington, it's staying at 26% instead of dropping down through 2022, which is very good news. It doesn't have to be your main home, and you file the taxes for the year that the system went in service. You can, of course, save because you're not paying utility for the electricity that you produce that you use in your home. And you can sell solar renewable energy certificates. For every 1,000 kilowatt hours that you produce, you get one certificate. And that's a little bit complicated, and I won't go into detail on that. Again, you can find out information about that online or on our website. Now, other ways you can help or be helped. In Pennsylvania, you can choose the company that generates your electricity. You can filter the search to pick 100% clean energy. So then you go to papowerswitch.com. I don't think this is in your notes that we've sent to you, so you may want to write this part down. And you can go to pplelectric.com to see ways to save for a variety of rebates and services. And there's also a section for if you're a business, as in maybe the Property Owners Association. I don't know whether that's considered a business or not, but you can go to pplelectric.com business rebates for information on how they can help you. And one more, the Clean Energy Co-op is a spin-off of Seeds, Seeds being a nonprofit. The Clean Energy Co-op is a cooperative, and it's an investment cooperative, and its mission is to sustainably develop renewable energy resources for a healthy and just energy future for our community. And it's using local investment and providing positive returns to our members. And these are two of the 5 projects they have completed. One is on the community center, Cooperage in Honesdale, and the other is at Will-O-Wisp Farm, which is in northern Wayne County. And there are 3 others, and I won't go into details on that. But if you're interested in that, go to that website and you can become a member of that investment cooperative. And with that, I'll be showing you some of our sponsors. And we want to thank you for sticking with us. We hope you did. Donations to support our work are most appreciated. And you just go click on the donate button on our webpage. And now we're open for questions and comments. Thank you.
And I would also like to thank you for listening. And just to make a note, we're all volunteers. Any money that it goes to Seeds goes 100% back into our mission of just providing education, supporting high school students to learn more about what we do and things of that nature.
Okay, so I have one question so far. Will Seeds give solar assessments for residences? And is that on a request basis?
Yes, we will give solar assessments to residents, and it's free if you're a member of Seeds, and it doesn't cost that much to be a member of Seeds. And so you just email us and ask for that, or you can call us too. There's a phone number on the website.
And how do you become a Seeds member?
Go to our website, and there will be a place for you to join.
Okay, here's another question. How do I stop sweating on toilet tank during summer?
Great question. So one of the simplest, well, I wouldn't call it the simplest way, but you might have to get a plumber involved, is you have a staging tank. So like I have a well, I have well water. And so what you need to do is draw your water from the well up into, it's a, you know, for lack of a better word, it's a second tank before it's usually around a 50, 60 or 70 gallon tank that's just for holding water temporarily. And it becomes acclimated to the same temperature as your basement. There's no heater involved. It's just a storage tank. So the water comes out of the ground, goes into that tank, and then mixes with the water that's already there. And then when the water goes from that tank, and every time you flush the toilet, now it's bringing, so the ground temperature is between 50 and 55 degrees. You have high humidity in your home. That's causing your toilet to sweat. Your basement might now be 65 degrees in the summer, maybe 70 degrees, maybe not. It might be a little bit cool, but it takes that water from 55, maybe takes it up to 65, and then it ends up in your bathroom where it might be 70 and humid. That's how you stop the sweating.
I used to have to do that. I used to have a sweating toilet, and they sell these little things that you hang underneath the tank with a sponge in it to soak up the water. It's not very pretty, but it does kind of catch the water from going down on the floor.
Do you have information on solar water heating with heat exchangers for domestic water and boilers?
You're gonna ask me that? Well,
Again?
yeah. Did you get that, Kathy?
Yeah, I got it, but I'm not sure I can answer that one.
Okay, good. Can you ask me one more time? I'm sorry.
Sure. Do you have information on solar water heating with heat exchangers for domestic water and boilers?
I think maybe I'm not understanding the question. You have domestic boilers that are traditionally powered by propane or natural gas, or you have solar hot water system, typically like a evacuated tube or a flat panel to make hot water. And so sometimes we have systems, it's called a solar hot water system, an evacuated tube. It kind of looks like a long tubes that might be 2 to 3 foot long. There might be 10 or 20 of them in a row. Typically, sometimes they're on the roof. And so what you do is you circulate water from that collector. It's collecting heat from the sun. It's collecting the sun's energy and putting that heat into the water, and it circulates to a hot water storage tank. And in most homes, it has a backup system of either electric or fossil fuel backup system. So if you have 3 days of no sun or heavy snow, so I'm not quite sure what the question is. I'm not sure if this is helping. You could restate the question, what exactly you want to know. I will share with you that solar hot water is a little bit out of favor right now. When you talk to those that are doing what I call net zero homes, they're really leaning towards PV, a lot of PV on your roof or in your yard, and using these hybrid heat pumps to really cut your cost.
So is there a place that someone could go for information?
Send it to me. That would be the easiest. Kathy, that's a Kathy, at seedsgroup.net.
Thank
A
you.
traditional solar hot water system costs around $7,000 installed, and it requires a backup system. And so that's one reason. So it has its application. And so I'm not trying to discourage you, but it has its application for certain situations where it can be a great tool. But that sticker shock can usually stops the project in today with the really high efficient equipment that's out there.
Hey, Larry.
Yes, go ahead.
What's your opinion on on-demand propane hot water heaters?
I think they're great. So the question is, what do I think about on-demand hot water heaters powered by propane? So when you're doing I would never take out a hot water tank. Well, I can't say never. Just taking out a perfectly good hot water tank and putting in an on-demand tank, you're going to see very little savings. But if that hot water tank were to fail, I would consider an on-demand. That's a good. Is that what you have?
Yes, that's what I put in. I took I had an older hot water heater, propane, and I put it on demand in.
Yes.
And I think there's a difference because it's only on when you're using the hot water. The rest of the time it's off.
Very good. Very good. And have you found that Do you have any time, like when you turn the water on and off, do you get a little bit of, like if you're taking a shower, you turn the water off, you turn it on, do you get a little bit of a cold water shower for like a second? Does that happen to you? Or do
No,
you-
I got a steady hot flow.
There
As
you
long as you
go.
use it. It helps because I have a son that loves the hot water, and it's all the water he wants comes out.
That's the number one thing, because I have a family of 4. Those kids stand in that shower. And so the number one reason to go to an on-demand system is unlimited hot water. You do have to pay for it, but it is unlimited, never runs out. Great question.
There is one thing that I'd like to say about propane and gas and all that stuff. Remember that does have an environmental footprint somewhere where that has to be drilled and pipelined and all that stuff. So it would be really nice if the electric ones which the electric ones made sense, especially if you were powering them on with solar panels.
So Kathy's talking about what's called distributed energy, where we create our own energy in our community. Like we can control like the sun and use that to make electricity. Whereas if we have to rely on a company to truck that propane to us for hundreds of miles, if not more. So great point, Kathy. These are all great questions.
All great questions. And I don't see any more. Thank you very much.
Well, I appreciate your attention and questions, and I think we went a little longer than we wanted to, but you all stuck with us, so I'm very thankful for that. And I know you can always send Kathy or I an email, or send Kathy an email, and there's a whole team of volunteers behind us that do as much work or more than we do, and we're just one of a couple, and there's a whole team behind us that are engineers, maybe retired engineers, and people that live this every day. So.
Yeah.
We're not, we're living it.
We're ready to go. Enjoy the day.
Yeah. Thank you, Kathy. Thank you, Larry. Thank you all for being with us. And thank you, Seeds, for being a resource to the community.
And thank you. And thanks, Larry, for helping. Well, not
Yeah,
just
Kathy.
helping, carrying a
Thank you,
lot of the
everybody.
load. Thank you.
All great, everybody. Have a great day. Enjoy the weather. Get outside. Go
Too.
for a walk.